Okay, I think that it was a little bit wasteful to give the nickname F in number one. So this time I'm just not going to use a nickname for the function. Instead, I'm just going to use the algebraic expression that gives the rule of correspondence for the function to name the function. And so this read from left to right says the derivative with respect to x of x squared minus xy plus y squared is equal to, and then the usual way to read things. So, of course, the derivative with respect to x of x squared is 2x. X times y, I meant to think of that as x is the variable and y is a constant. So x times a variable, the derivative of that, sorry, x times a constant. Say this was x times 5. The derivative with respect to x of x times 5 would certainly just be 5. And so I meant to leave just y there. And the derivative with respect to x of y squared is 0. Okay, and the derivative with respect to y of the same function is, well, this time the derivative with respect to y of x squared is 0. The derivative with respect to y of x times y, you kill off the y, right? The derivative of y is 1, and you keep the x, which was the constant. Plus the derivative with respect to y of y squared is 2y. So here I have used the distributive property of the derivative. Then I move on to 3. Again, though the book seems really fond of saying f is equal to, it does that so that it can give concise instructions for exercises 1 through 22. It says find df dx and df dy for the following things that we might call f. There's no need for you to refer to everything there as f, though. Certainly it's weird to give everybody the same nickname. I wouldn't take a room full of 70 of my students and call them all Thomas. That would be very confusing. Anywho, end of rant. The derivative with respect to x of the product of x squared minus 1 and y plus 2. Now, at first I did not write the bigger parentheses here. I simply had the two smaller parentheses. But then I thought to myself, it is not clear whether this means the derivative with respect to x of just the first factor and then ignore the second factor. Well, so to clear that up, I put this in parentheses and I said the derivative with respect to x is hitting the entire thing inside of the what do you call it, right angle parentheses. All right, now I made a mistake. Let's check it out. The derivative with respect to x of the product of two things, well, there's something called the product rule for the derivatives. It's the derivative of the product of two things is the derivative of the first, the derivative of x squared minus 1, which is 2x, times the second, y plus 2, plus the first thing times the derivative of the second. And the derivative with respect to x of y plus 2, since y is not the variable that we are taking the derivative with respect to, the derivative with respect to x of y plus 2 actually is 0. So that 1 right there ought to have been a 0. Okay, and of course that makes this 2 times x y plus 2. Did that fit on the screen? Not quite. Move it over. Arrgh. Okay, and there I want to point out that I used the product rule. Okay. Now, the derivative with respect to y of the same expression. Let's check that out. X squared minus 1, y plus 2. Now, it's not clear to me whether d dy here, this derivative operator, is meant to hit only the first term and not the second, or vice versa, so I will put this in parentheses and say, that helps me to clarify that this derivative is meant to hit everything in here. And again, by the product rule, I have the derivative of the first factor with respect to y. Since the first factor only involves x's and numerical constants, that is 0. And I add to that the first factor times the derivative of the second factor with respect to y, the derivative of y plus 2 with respect to y, that is 1. So that is x squared minus 1. Okay, and I could say by the product rule again, but that just doesn't feel like it would help anything.